So we're going to start working today with these indefinite integrals. And what makes these ones, I think we talked about this the other day, but what makes these indefinite integrals is because they don't have a lower limit or an upper limit. So there's no limits on these integrals, which means that when we integrate this function 5 dx or 2x cubed dx or 1 over x to the 5th dx or whatever it happens to be, when we integrate those, we're going to end up getting a function. We're not going to get a numeric answer. So we're going to get a function that represents what the area under this curve would be if we did put limits on it. So the way we're going to start out thinking about this is all we need to do if we're trying to find the integral of 5 is come up with a function whose derivative is 5, because derivatives and integrals or antiderivatives are opposite operations of each other. So what's a function that when you take its derivative gives you 5?
$5x.
5x, right? 5x, if you take its derivative, gives you 5, doesn't it? So we have a small issue with this. This is correct, partially, that you definitely get 5 if you take the derivative of 5x, but 5x isn't the only function that when you take its derivative, you get 5. For example, I could think of a lot of other ones, like 5x plus 1. If I take the derivative of that, I still get 5, right? Or if I take the derivative of 5x plus 2, or if I take the derivative of 5x minus 1,000, those all come out to be 5 when you take their derivative. True?
Yeah.
Okay. So instead of just saying 5x is the integral of this, we have to say that the integral of this is 5x plus any constant. And so anytime you evaluate an indefinite integral, it will always be some function plus any constant, because you could always have a constant attached to this so that when you took the derivative, it would go away and just give you that function. Does that make sense to everyone?
Yeah.
Cool. All right, so that was the first one. The integral of 5 dx is 5x plus c. And even though there's no variable within this 5, we know that it needs to be an x because this is a dx. If that was a dt, let's say, then this would be 5t plus a constant. Or if this was dy, it'd be 5y plus a constant. All right, cool. We're all good. We're all on the same page. Everyone's feeling all right so far?
Yes.
Great. All right. Now what about 2x cubed? Well, we just need to find a function that when you take its derivative gives you 2x cubed. What would that be?
1/2 x to the 4th plus c.
Yeah, it should be 1/2 x to the 4th plus some constant, right? And that makes sense. If I take the derivative of 1/2 x to the 4th, that gives me 2 when I multiply the power by the coefficient, and then x to the 3rd because we drop down by 1. Okay. And so effectively, all we're doing here is we're doing the power rule in reverse. And so we might note that what this does is 2x cubed becomes 2x to the 4th, we raise the power, and then after we've raised the power, we divide by the new power. So the power rule in reverse is telling us to raise the power by 1, then divide by the new power. Okay. And any problem that could have been differentiated using the power rule, or almost any problem that could have been differentiated using the power rule, can be integrated by using the power rule also, just doing it in reverse. Everybody good with that?
Good.
Okay, and we might even have noted that this 5 dx, well, 5 is the same as 5x to the 0 power, isn't it? Right, x to the 0 power is 1, so 5 is 5x to the 0. And we could use the power rule on that. It would go up to be 5x to the 1st divided by 1, which is the 5x that we got. And then we just remember that we always attach the plus c to it. Any issues? Everyone okay? Okay. All right, so what about this one? Is this one that could have been differentiated using the power rule?
Yes, it's a negative exponent.
Yeah, we just wanted to write it as a negative exponent, right? So let's write it as x to the negative 5 dx, and then raise the power up by 1. So what does that become? X to the negative
4.
4. And we'll divide by negative 4. And we'll add a constant to it. And we might want to rewrite this as negative 1 over 4x to the 4th plus a constant. But either one of these would be an acceptable answer. And what about this one? This one could be done with the power rule. This is x to the 3/4 dx, right? Power over root. And so what would that become? That should become x to the 7/4 divided by what? Divided by 7/4, right? Plus our constant. And normally we won't write this thing divided by a fraction. Since we're dividing by a fraction, we'll flip it. We'll take the reciprocal and multiply. So we'll just call this 4/7 x to the 7/4 plus a constant. And if we were to try to differentiate that to see if it came out to be this, we'd do 7/4 times the 4/7, that'd be 1. X to the 7/4 minus 1 is 3/4, and we'd be good. Everyone feel all right with those 4 that we just did?
Yeah.
All right, let's do a few more. So next thing I'm going to say is anytime you have a trig function, if you don't immediately know the integral, we want to simplify first. So do you immediately know the integral of tangent x over secant x? Probably not. So let's simplify it. What is tangent x? It could be written as sine x over cosine x. And secant x could be written as 1 over cosine x. And what does that become?
Just sine x.
Just sine x. And so now we just want to know what's the integral of sine x. Now, up in the Google Drive, up in the other documents folder, I've put up the list of all of the integrals that I expect you to know and memorize. But for right now, let's see if we can figure out what this is. We're looking for a function that when we take its derivative gives us sine. So what function, when you take the derivative of it, gives you sine?
Negative cosine x.
Yep, negative cosine x. Right, because the derivative of cosine is negative sine. We know the derivative of negative cosine is positive sine. So this should be negative cosine x plus our constant. Good or no? All right, let's do the next one. What should 5x cubed become?
Five over 4x to the 4th.
5/4 x to the 4th. And then what about cosine of x? If we integrate that, that means we're looking for a function that when we take its derivative gives us cosine. That should be
Sine.
should be sine x plus our constant. Everyone still good? All right, what about this one? 8t cubed, what should that become?
Two t to the 4th.
Okay, go up to the 4th and divide by 4. And then the 6 root t, that's a 6t to the 1/2, right? So we go up to 3/2 and divide by 3/2, which would be the same as multiplying by 2/3. So what's 6 times 2/3?
4.
4, and it'll become t to the 3/2. And then this one is t to the negative 3, right? So we'll go up to t to the negative
2.
2.
2, and divide by -2 plus a constant. And we might rewrite this as 2t to the 4th minus 4t to the 3 halves minus 1 over 2t squared plus a constant. But I'd take either one of those. Good or no?
Good.
Cool. All right, we'll do one more page of these, just a couple problems here, and then we'll be done for the day, and we'll pick up with this again tomorrow. So, what do you think we should do with all of this nonsense inside of there?
Simplify it.
All right, how can we simplify it? Expanding out the x squared, you mean? Or the x squared minus 1 squared? Is that what you mean?
Yeah.
Okay, so x squared minus 1 squared is x to the 4th minus 2x squared plus 1 all over x squared dx. And now what?
Cancel out the stuff that we can.
Meaning what?
So we split them into their own fractions and then simplify them.
Perfect. Anytime you have a rational function where the denominator is just a single term like x squared or x or 7x cubed or something, if it's a rational function, just divide each term in the numerator by that term in the denominator. Just do term by term division here. X to the 4th over x squared is x squared. Negative 2x squared over x squared is negative 2. And 1 over x squared is x to the negative 2. And then that should turn it into something that you can nicely anti-differentiate using the power rule. Everybody good with that process?
Yes.
All right, and what does that give us? What's the integral of x squared?
X cubed over 2. No, sorry,
Cubed over
x cubed over 3.
3, okay, good. And what about the minus 2?
Minus 2x.
And the x to the negative 2 should go up to become x to the negative
1.
1 over the negative 1 plus our constant. And I always like to write those negative exponents as just positive exponents. So you don't have to, but I think it looks a lot nicer this way. And then I can pull the negative out in front. Everybody good?
Good.
All right, what about this one? Do you immediately see an integral for that?
Nope.
Nope. So let's see if we can simplify. Let's try and get rid of the fraction first. Because that's kind of what we did in the first one, right? We just simplified it down to get rid of the fraction. So if I want to turn this into something without a fraction, what does that become? What's 1 over cosine?
Secant.
Secant. And what's 1 over cotangent?
Tangent.
All right. And so now, hopefully, you see immediately what that should integrate to become. Because you should know a function that when you take its derivative gives you secant times tangent.
Secant
Should just be secant. Yep, secant u plus a constant. Good or no? Hopefully that's all good. That is all we're going to do today. Any questions?